In today's splicing video, we're going to look at what is a splice and when do I need one? The two main types of splicing, fusion splicing and mechanical splicing. The secret of a good splice. How do you actually do a fusion splice? And where can I get a more detailed guide on all of this? What is a splice? In simple terms, a splice is when you join the ends of two optical fibres together. This should form a strong, smooth connection so that when light passes through, it is not scattered or reflected back at the splice point, so there is minimal loss. When might you need to do a splice? A splice can be a cost-effective and time-effective solution when you need to attach a connector onto the end of a pigtail, you need to make your cable longer, or the cable becomes damaged. So rather than replace the whole cable, you want to cut out the damaged part and join the rest back together. There are two types of splice, fusion and mechanical. Let's start with fusion splicing. In a fusion splice, the ends of the two fibres are melted or fused together to become one single cable. This creates a joint that, if done correctly, should be just as strong as the natural fibre. The completed splice is usually covered by a heat-shrink plastic sleeve, which protects and strengthens the joint. How is this done? Here comes the technical part. First and most importantly, the fibres need to be stripped, cleaned and cleaved precisely. We'll cover this in more detail in our demonstration later. To fuse the ends of the two fibres together, you need heat, normally in the form of an electric arc. What is an electric arc? Well, according to encyclopedia.com, an electric arc is a device in which an electric current, that's a flow of electrons, is caused to flow between 2 points separated by a gas. Did you know that one example of an electric arc in nature is a lightning bolt? The heat can also be provided by a laser, gas flame, or tungsten filament through which current is passed. A fusion splicer is a piece of specialised equipment that can do all of this for you. Mass fusion splicers can do a complete ribbon of fibre, that's up to 12 splices in one go. We'll show you how to use a single fusion splicer later on in this video. The second type of splice is a mechanical splice. Where fusion splicing moulds the ends of two fibres together to become one single fibre, mechanical splicing is different. It just aligns the two fibres in the correct position and holds them precisely in place to allow the light to pass through. This is done by using plastic or glass alignment sleeve just larger than the fibres themselves, aided by the use of optical glue or index matching gel at the joint to reduce loss and reflectance. The fibres are not permanently joined together, just held firmly in place. So, how is this done? Just like with the fusion splice, the fibres need to be stripped, cleaned and cleaved precisely. For the mechanical splice itself, just purchase a commercially available mechanical splicing toolkit. Follow the manufacturer's guidance on how to insert the fibres correctly into the splice component and hopefully you'll get the optimum result. There are many different types available and plenty of YouTube videos to help you out if you're unsure. So which is better? Well, usually this comes down to a question of cost, use, quantity and performance. Let's look at the pros and cons of each. A fusion splicing machine is more expensive than a mechanical splicing kit and involves a certain degree of training to use. However, the cost of an individual fusion splice is significantly lower than a mechanical splice, once you've purchased the machine, that is. A fusion splice, if done correctly, provides a continuous connection, thus offering a lower insertion loss, typically less than 0.1 decibels, lower reflectance, and thus a very high performance. This ensures a strong signal and better protection against cable failure. The loss in a mechanical splice is usually higher, typically between 0.2 and 0.7 decibels, and they have a higher reflectance. So from the previous screen, the obvious difference is that fusion splicing makes it one continuous fibre at the end, whereas a mechanical splice is simply just two fibres tightly and precisely held together. It is also preferable to use a fusion splice with single-mode fibres, whereas a mechanical splice would typically be used for multi-mode fibres. Now, on some occasions, it isn't practical or convenient to do either splicing procedure. For example, if you're an engineer balanced at the top of a distribution pole with a damaged connector hanging from the end of your cable. In this scenario, you would use a field fit connector. This is not as robust or waterproof as a fusion splice, but they can be installed in situ in a matter of minutes, without the need of any machinery. There is, of course, a degree of skill involved in ensuring the connectors have a minimum insertion loss once installed, but it is a much more convenient solution in the field when required. So, what's the secret to a good splice? Here's the big reveal. The secret to a good splice is in the cleaving. You need a straight cleave on both fibres. This comes from having clean, well-maintained equipment and taking the time and effort to learn the proper techniques to use it.